While vaccines wage pandemic war, BioDrop is the free voice and smell biomarker app that gets us back to business quicker and safer. A protective layer accessible to all. Let me show you how. First, we need to understand the problem that made SARS-CoV-2 into a pandemic. SARS-CoV-1, back in 2003, had about 10% higher fatality rate than SARS-CoV-2 in 2020. It had similar transmittability and it was contained. Here's the difference. Symptom onset was 2 to 3 days before infectiousness for SARS-CoV-1. For SARS-CoV-2, symptom onset is 2 to 3 days after infectiousness. Take 2 or 3 more days from symptom onset for testing, and by the time an infected person gets isolated, most of the infectious spreading has already happened. As a signal for mitigation, symptom onset worked well for SARS-CoV-1, but for SARS-CoV-2, it's a big failure. A better signal is urgently needed. As vaccines roll out to wage pandemic war, this particular problem may actually worsen. We know that vaccines reduce symptom onset and they reduce severe illness. But vaccines don't stop infectiousness. Without symptoms, a vaccinated person may become an asymptomatic spreader. It's hard for those who are vaccinated and asymptomatic to remain vigilant so they avoid unknowingly spreading the virus. Vaccines are the big armaments that are now waging this war. No one knows how long it will take to win this war. Viral mutations are proliferating, allowing the virus to escape the clutches of the vaccine. Immunity wanes over time. Booster vaccines and variant vaccines are in the future as the war progresses. The 80 to 90% worldwide vaccination levels needed for containment aren't expected in the near term. While vaccines wage pandemic war, a better signal is needed to protect us and get us back to work quicker and safer. Dr. Dana Small, cognitive neuroscientist at Yale University School of Medicine, has been working on a better signal. It's well known that loss of smell is highly associated with COVID-19. What has not been known is if loss of smell is a better signal than symptom onset. Dr. Small led the clinical study using her Yale Jiffy smell test that uses a smartphone and common household odors like peanut butter and vinegar to demonstrate that loss of smell occurs a median of 2 days prior to detectable PCR signal. Dr. Small thinks the Yale Jiffy is a better signal. Dr. Small is collaborating with us now to embed the Yale Jiffy into BioDrop. Dr. Rita Singh, human voice profiling scientist at Carnegie Mellon University School of Computer Science, has been working on a better signal. Dr. Singh has demonstrated vocal fold asymmetry that can be transcribed from recording voice samples on a smartphone into vocal phase portraits is highly associated with COVID-19. MIT has demonstrated that vocal biomarkers transcribed from voice recording on a smartphone can be used to diagnose asymptomatic cases of COVID-19 with 100% sensitivity and 83% specificity. Dr. Singh is collaborating with us to embed vocal biomarker transcription into BioDrop. How much better are the signals that can be derived from BioDrop's biomarkers? Dr. Daniel Larimore, computational social scientist at University of Colorado School of Computer Science, can tell us. Dr. Larimore actively builds and analyzes infection curve simulation models of the pandemic. He simulated the infection curve with no mitigation. Lots of infection and lots of death result. Then he simulated the infection curve if we could do a PCR test on everybody once a week. Even though it doesn't seem possible to do that under any conceivable strategy, but if we could, infection gets controlled but does not clear. Finally, he simulates the infection curve if we could test for smell loss every day and assumed that infection would be detectable 1 day after PCR detection. With that, infection clears within 10 weeks. With smell loss occurring a median of 2 days prior to PCR, demonstrated by Dr. Small at Yale, infection clears even sooner. This is a better signal. The BioDrop app transcribes biomarkers. Biomarkers are biological measures of biological states. The smartphone microphone transcribes sound of voice. The unsupervised generalized label magnitude scale uses the smartphone screen to transcribe smell sensation. It was developed by Dr. Small at Yale University School of Medicine for this project. Checkbox controls use the smartphone screen to transcribe signals. These biomarkers are all associated with COVID-19. Mapping algorithms map these biomarkers to protocols that generate useful signals. Mapping algorithms are based on clinical studies that describe the associations between biomarkers and COVID-19. Existing published studies from Yale University and Carnegie Mellon University are the basis for the initial handcrafted mapping algorithms. To make better algorithms, we are sponsoring Yale University's clinical study of daily multiplex biomarkers paired with daily saliva PCRs. The data sets from this study will train artificial intelligence algorithms to improve diagnostic performance. After that, we expect to sponsor Advent Health University's clinical study of daily multiplex biomarkers paired with standard of care PCRs. This will generate a much larger number of data sets to train deep learning artificial intelligence algorithms to clinical precision. With these initial handcrafted algorithms, BioDrop can host entry protocols on behalf of congregating venues. These will be a marked improvement over the current standard of care relying on temperature checks. Venues can open quicker, safer, and at higher capacities with these better protocols. The artificial intelligence derived from Yale University's clinical study we are sponsoring will improve the precision of entry protocols so that they can open quicker, safer, and at even higher capacities. Finally, the deep learning artificial intelligence derived from Advent Health University's clinical study that we expect to sponsor will drive clinical protocols for diagnosis, treatment, and mitigation based on FDA emergency use authorizations. BioDrop is a protective layer that is accessible to all. It's for those who have never been infected. It's for those who have recovered from infection. It's for those who have been vaccinated. It's for those who are asymptomatic. It's for those who are vulnerable. It's for those who are invincible. It's a layer to protect everybody in each state of their association with the virus. BioDrop, the better signal that gets us back to work quicker and safer.